Hello and welcome to the channel. This is Mish with another LUMIX video. Today I'd like to go over powering Panasonic LUMIX cameras for extended periods. I'll cover a few products in this review: a newer V-mount plate, newer 50 Wh mini V-mount battery, and finally the Panasonic DCC-18 dummy battery. Let's start with the dummy battery by Panasonic. Here it is. Naturally, it's the same size as a regular battery, except for the lower part, where there's a small indentation from which a flexible cable extends. The cable is easy to move in any direction, so I'm not too concerned about it breaking over time. Now let's put it into the camera and see how it performs. The battery compartment door has a little notch to allow the cable to pass through. And this small rig cage I'm using has a cutout at the bottom that lets the cable run cleanly when the camera is placed flat on surface. Everything fits very well, nicely designed and thought through. When connecting this, make sure to use a proper cable. This one is a 100 watt USB-C to USB-C cable. Now let's take a look at the newer V-mount plate for V-mount batteries. Here it is, it's called the PS007, it came bundled with the battery. It feeds standard 15mm support rods and offers a wide range of motion, allowing you to position your V-mount battery in nearly any orientation. There are a lot of extra mounting holes, an Allen wrench is included, and you can use it to reposition the plate as needed. The battery fits into place with a very satisfying snap. As you can see, it doesn't stick out too far from the mounting plate. Nice and compact. Now let's see it mounted on a rig. Here it is. By loosening this screw, you can reposition the battery to suit your rig. You can have it facing inward toward the camera or outward, or mount it vertically. Quick and easy adjustments. Using the included wrench, you can also mount the battery horizontally. In this configuration, your USB-C cable fits snugly into the rig, keeping the cable secure so there's no risk of bumping, bending, or somehow damaging it. Let's take a closer look at the battery design. USB-C and USB-A ports are on this side. Please note, the USB-A port does not support 9V 3 amps, which our cameras require, so it's essentially useless for powering this setup. The USB-C port provides power delivery, which is what you'll use to charge or power the camera. On the other side, there is a D-tap connection, and on top are 8 and 12 volts DC barrel outputs. This rubber flap isn't great, but it gets the job done. Everything else is pretty standard. There's a display and power button. The screen shows the current draw from DC and USB ports, but not from the D-tap. Now let's talk about charging. I connected my 65 watts phone charger and you can see the battery drawing 20 volts. I ran some charging tests. It charged from 0 to around 50% in just 30 minutes, amazingly fast. However, around 60% and 40-50 minutes in, the battery displayed an over-temperature warning on its screen. I also tested a 45 watt charger and the results were identical. I was a bit puzzled and concerned, so I checked the manual and discovered this. The battery's temperature protection activates at 47 degrees Celsius during charging. However, when the battery is discharging, powering the camera, it's rated to operate up to 57 degrees Celsius, so they've been very conservative with charging temps, while allowing higher temps during use, which is a good thing. But the implementation is a bit weird. It flashes OT on screen and you can't really tell what's happening. By the way, I was in a cool environment with AC on and the battery felt only slightly warm to the touch. Important thing to note, when the OT appears on screen, charging doesn't stop, it just slows down. From what I've observed, the battery starts drawing much less power. For example, when OT warning disappears, power draw is at 12 to 15 volts. This keeps temperature under control while continuing to charge. A full charge took about 1 hour and 40 minutes. Also, when the battery nears 95–97% charge, it enters a kind of trickle charge mode, drawing 12 volts intermittently. Now let's go back to powering the camera. I've plugged the dummy battery into the camera and connected the USB-C port. Turning on the camera. As mentioned earlier, USB-A doesn't support 9V 3A, but USB-C does, and the camera powers on. The cold start of Lumix cameras takes a moment, but finally the screen confirms the camera is drawing 9V from USB-C. I can use the power button on the battery to cycle through different display modes, including current draw. However, the amp readout is often weird. It should show 3 amps, but it displays 0.6 amps. So I'm not sure how useful that is. Let me know in the comments if you know what's happening here. Holding the power button shuts off the battery and all connected devices. Now a few words about the behavior of the USB-C power delivery port. When I power off the camera, the battery detects no power draw and shuts off after a few seconds. Here's the interesting part. When I try to power the camera back on, the battery doesn't respond. It doesn't detect a new power draw. Pressing the battery button does nothing. The screen shows 0 volts being drawn. To reinitiate power, I have to unplug and replug the USB-C cable. Only by physically reconnecting the cable does the battery deliver 9 volts again, and the camera powers on. From what I understand, this is a limitation of USB-C power delivery. Since it supports a wide range of power, a handshake needs to occur at the time of connection to determine how much power to deliver. I think that's why physical reconnection is required. Let's test this further with an external monitor. I'll power it using the 12V output. As you can see, the display now shows the 12V port active, and I can turn the monitor on. Now, if I hold the battery's power button, both the monitor and camera turn off. If I press the button again, the battery powers on and the monitor begins drawing power, but not the USB-C port. Again, only dumb ports like 12V barrel out work instantly. USB-C requires a proper connection handshake. Let's now test the D-tap port. I'll power the monitor using a D-tap to 12V connector. Interestingly, the monitor turns on instantly, but the battery screen shows no information. No voltage, no amperage. D-tap seems completely isolated from the battery's monitoring electronics. The screen becomes useless except for showing overall percentage. Even turning off the battery via the power button doesn't stop D-tap, it stays on. The monitor continues running. So that's the behavior of various ports. Now for some runtime test. The main advantage of using a dummy battery is that it frees up the USB-C port, so you can use the LUMIX S5II amazing SSD recording feature. Panasonic's internal battery life is poor and becomes abysmal when SSD recording is enabled. So for my first test, I rigged out the camera, used the dummy battery with the newer 50Wh mini V-mount battery, and added an external monitor powered from the 12V output. Basically, a worst-case, power-hungry setup. Recording was done in ProRes 5.8K 422HQ to an SSD. That's the beefiest codec of the camera. After about 2 hours, the battery hit 10% and displayed a flashing battery icon, suggesting it was time to swap. But I pushed it to the limit, and exactly 2 hours and 15 minutes in, the camera shut off. The monitor kept running for a few more minutes. So yeah, the battery can go a bit more at 0%, but you shouldn't rely on that. Once the warning appears, swap the battery. If you're curious, when I powered the camera on using its standard battery, the file was lost. That's the risk of dummy batteries with any camera. If power is cut unexpectedly, you lose the entire file with no recovery. That's why I'm always cautious when using this kind of setup. But with nearly 2 hours of runtime, it's manageable if you replace the battery on time and use trusted batteries and cables. Remember, charging takes about 1.5 hours. and running under heavy use is around 2 hours and 15 minutes. So if you own 2 of these batteries, you're set. Charge one while using the other and never run out of power on set. And that's just great. Alternatively, you could get a higher capacity battery. For my second test, I recorded a standard MOV file in 6K OpenGate 25p to an SD card. After nearly 3 hours, the battery was at 50% and my SD card was almost full, so I stopped the test out of boredom. But the point stands, 3 hours of use and only half the battery drained. Excellent performance. Now, if you don't need to free up the USB-C port for SSD recording, you can use the battery as a glorified power bank by connecting it directly to the camera's USB-C port without the dummy battery. I tested this setup while recording 6K MOV and the results were nearly identical. After 3 hours of continuous recording, the V-mount battery was at 50% and the internal battery remained at full charge. Now for some final thoughts. I've used this 50 Wh Neewer V-mount with and without the dummy battery for a little over a month and can confirm it's a reliable and solid power option for LUMIX cameras. Hey, I even powered my trusty old GH5 with it. The only quirk I've found is the battery's overtemperature behavior during charging. A simple solution is to use fast charging on set when you need quick turnaround and switch to slower, cooler overnight charging when you're at home and not in a rush. This will probably increase your battery's lifespan due to less overheating. You should also be mindful how much power you will be drawing from the battery. As we saw from charging, the battery heats up when it's running at 45 watts, which is its maximum charging power. LUMIX cameras need about 27 watts to run, and during operation the battery never felt even slightly warm, but it might definitely get there if you continue loading it with more and more devices. Frankly, I wouldn't power anything but the camera and occasionally a monitor with this setup. Thanks for watching. If you found this helpful, please like and subscribe and drop any questions in the comments. See you in the next one.